Assalamu alaikum. Inshallah, in this tutorial, we will learn how to interpret the phase diagram, how to indicate the phases in any question, and the composition of each phase. Let's start with the first question. Here we have a question that says, cite the phases that are present and the phase composition for the following alloys. Okay, so I have an alloy that consists of 75 weight% of SN and 25 weight% of PB at 175 degrees Celsius. So I have this phase diagram. Okay, here the x-axis represents the composition of SN. So he said 75 weight%. So 75 is here. Okay, so if I draw a line that represents the 75 composition of SN, it will be something like this. Okay, then at 175 degrees Celsius, so I have the line passes through the whole phase diagram, but I need specifically at 175 degrees Celsius. So I need also to draw another line. This line that we already draw, usually we represent the composition of the alloy given in the question by C0. Okay, let's draw the line of the temperature, 175 degrees Celsius. So if this one is 175, so this one is 150, so this one is 175 approximately. Okay. So now the intersection between these two lines will give you the point that represents this alloy at this temperature, 175 degrees Celsius. Now the question asked to cite the phases. This point is in the alpha beta phase, so the phases are alpha plus beta. So direct or straightforward. And the phase compositions, we need to calculate the phase compositions. In order to calculate the phase composition, we know that the phases are alpha and beta. Okay, alpha alone is in this region, beta alone is in this region. So I will construct a line from the point that I have until I reach the alpha region. Then I will the value in corresponding to the intersection with the line that I will construct, like for example like this, I will draw a line. Okay, from this point until I reach the red line, which the boundary of the alpha region. Okay, so then I will construct another line from this point, the blue point, until I reach the x-axis. So this value approximately, it is 15. Okay, so that is C of alpha. Okay, the composition of alpha phase, okay, is 15 weight% SN. So the alpha phase is 15 weight% SN, and it is 100 minus 15 is what is 85 CU BB. Okay, weight%. Okay, so and also the same thing I will do for the composition of beta phase. Okay, let's for example this line, this color. Okay, I will go from the point that I have until I touch the red line, which is the boundary of the region of beta phase. Okay, then I will construct a line until I touch the composition in the x-axis. It is approximately 98 weight% for SN. So C for beta, the composition of beta is around 98 weight% of SN and 2 weight% of BB. يعني you can approximate, maybe you will have different values or different number, بس يعني approximately around this value 98. Okay, that is for this alloy. For part B, we have another alloy. I have 55 weight percent Ag, so this x-axis also represents Ag, so I will use directly the 55. So 55 is here, so I will draw a line from the 55 composition. So it will be something like this. Okay, then I have at which temperature 900 degrees Celsius. 900 degrees Celsius from the y-axis on the left. So it is here. So the point that represents the alloy is this point, and it is in the liquid region, so the phase existed is liquid. Okay, now I want to calculate the composition. Already I have only one phase, so which is liquid, so the composition of liquid Cl is equal already the same composition of the alloy, 55 weight percent of Ag and 45 weight percent of Cu. So when you have only one phase, it is the same composition of the alloy itself. Okay, so let's see part C. This alloy, we have 30 weight percent Pp. So this x-axis represents the Pp, so it is 30%, so it is here. Okay, so I need to draw a line from the 30 weight percent composition, a vertical line. Then I will draw a horizontal line that represents the temperature, which is 425 degrees Celsius. So it is approximately here. Okay, so here the intersection represents my point that represents the alloy. This point is in the alpha region, so I only have alpha phase, and the composition, since I have only one phase, composition of alpha is the same like the composition of the alloy itself. So I finished the question. So it is so easy and straightforward. Here we have another question. It says that you have a 90 weight percentage of Ag and 10% Cu. So I have this graph. The x-axis is for Ag, so the composition of Ag. So I will use the 90 weight percent. Okay. So 90 is here. I will draw a line that represents this one. Okay. Sorry. Okay. And what else? What he is saying, it is heated to a temperature within the beta plus liquid phase region. So the point of this alloy is heated until it reaches the beta plus liquid region, which is this region. So it is something here on this line in the beta liquid region, but I don't know exactly where the point on the line in this region. Also, he is saying if the composition of the liquid phase is 85 weight percentage Ag, the composition of the liquid L, so Cl is equal to 85 weight percentage Ag. So where is the 85? 85 is here. Okay, so I need also to draw a line that represents the composition of the liquid. Okay, so I draw also this line. So now I have C0, it is 90. Okay, and I have C for the liquid, it is 85. Let's continue the question. Using the figure below, determine the temperature of the alloy. Now the alloy is in this line. Okay, in the region of beta plus alpha, beta plus liquid, this region, okay? But I don't know exactly where on this line. It is here, 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 I don't know, okay? So in order to know, I have another information, which is that the liquid phase has a concentration or composition of 85%. So this line, the blue line, before this line, I have 100% liquid, right? It is written here, it is liquid. And this line, after this line, I have beta region, the beta phase region, okay? So it is also here, I have 100% beta. The weight percent for the beta here is 100%. So now, in order to find the temperature that correspond to 85% composition of the liquid, I need to touch this line, the blue line for the liquid, because I am given the composition of the liquid, okay? So I will make intersection between the blue line and the line for the composition of the liquid, okay? So the intersection is this point. This point represents the liquid region, because the liquid region will come from this, the liquid phase will come from this region, okay? So whenever it says 85% Cl, that means that I need to take this intersection between the line and the line that represents the Cl and the blue line. Why? Because what he means by 85 composition liquid, that if I draw a horizontal line until I touch the line of the C note, this point, this new point, let's draw it in red, represents the alloy, okay? So the alloy is here, okay? Because what we did in the previous questions, that we already had the point itself, okay? In the first part, for example, part A, I had the point itself, okay? This point. Then in order to calculate the phases, alpha and beta, I draw a horizontal line to the left and I draw a horizontal line to the right. Now it is the opposite. I have already this point, the blue point, okay? And I need to find the corresponding point which represents the alloy, okay? So it is the same thing. So that is why I need to go until I touch the limit or the boundary of the other phase. Here it is alpha. In the question number 3, the boundary line, which is the blue line, it is the boundary of the liquid. So that is the only difference, okay? So the temperature corresponding that will intersect these 2 points are, if I draw a horizontal line that intersect these 2 points, I will have a temperature which is approximately 850 degrees Celsius. So I will say that the temperature is 850 degrees Celsius. The composition of the beta phase in part B, it is asked to calculate the composition of beta phase. So C beta, okay? In order to calculate C beta, now I have the point, which is the composition of the point itself, or the point that represents the alloy, and I know also the composition of the liquid. The same thing, I can find the composition of beta. I only need to draw a horizontal line to the right until I touch the boundary of the beta phase, okay? I will draw this distance, okay? Then I need to go to find to the x-axis and find the intersection with the x-axis in order to calculate the composition of beta phase, okay? So if I draw a line until I touch the x-axis, it is approximately 95. So C beta is equal to 95. So this one, the composition of beta is 95 weight percent. Now, in order to calculate in part C the weight fraction, I need to use the lever rule, okay? the equation I need to calculate that for both phases, which is liquid and also beta, because I am given that the point is in the beta liquid region, so I need to calculate the weight for the liquid, and also I need to calculate the weight for the beta phase. Okay. The lever rule, in order to calculate any weight, it is the ratio between the lines. I have the total distance from the liquid to the beta phase, which is this line. Okay. Let's draw it down. It's better. I think it will be more clear. So here I have what? I have this one is C liquid, and this one is C0, and this one is C beta. Okay, so this line is the total line. Okay, and let's draw this line is the total line, and the red line represent the percentage of the beta phase, and the green line represent the percentage of the liquid phase. Okay, so if I want to calculate WL, it will be the total line will be in the denominator. Okay, so it will be C beta not CL, the total line. So I am subtracting the most right value minus the most left value. Okay, over or in the numerator I will put C beta minus C naught. So it is the opposite. I want to calculate the liquid, the weight fraction of the liquid, which is already in the left. I will take the line in the right. Okay, so it will be C beta minus C naught, always the right minus the left. So it will be 95, which is C beta, minus C naught, which is 90, over C beta, which is 95, minus CL, which is 85, and this will give you 0.5. If I want to calculate the weight fraction of beta, it is directly 1 minus 0.5. It is the remaining. The addition of both of them, the weight fraction of liquid and the weight fraction of beta must be equal to 1. So it is 1 minus 0.5, which is 0.5. Also, or also I can do the same thing like what I did in the weight fraction of liquid, and I will say that I have the weight fraction of beta is equal the total distance. It is always the same, CB minus CL, the total distance, the value on the most right and the value on the most left. Okay, and now I want to calculate for the beta. Beta on the right, I will take the line on the left, and it is the opposite. So I will take the red line, which is C naught minus CL. Okay, so it will be 90 minus 85 over 95 minus 85, which is also equal to 0.5, or you can say directly 1 minus 0.5 is equal to 0.5. And that is it for this video, inshallah.